In this video, we will be learning about projection of solids. So to understand the projection of solids, you need to know about what is meant by projection of a. You need to know about orthographic projection. You need to know about projection of points. You need to know the projection of lines. Then only you can understand the this projection of the solids. Okay. So whenever I say solid, it is a three-dimensional object. So it has length, width, and thickness. Okay. Length, width, and thickness. It has three dimensions. Next, you need to know what are the different types of solids. So solids is divided into two types. One is right solid and oblique solid. And this right solid is again divided into two types. One is polyhedron and solids of revolution. And coming to polyhedron, again it is divided into regular polyhedron, prism, pyramid. And coming to solids of revolution, so here we will be having a shape. That shape is revolved 360 degrees and we will be generating cylinder, cone and sphere. So in the regular polyhedron, we have total 5: tetrahedron, cube, octahedron, dodecahedron, icosahedron. So these are the different polyhedron we will be having. So out of this, mainly we will be using tetrahedron and cube. Next is the prism. Prism is nothing but the bottom shape and top shape. Both are the same shape and joined by the bottom points to the top points. Then you will get the prism. Next is the pyramid, and prism has also different shapes, top and bottom, triangular, square, pentagon, hexagon. Next is the pyramid. In the pyramid bottom we have a shape. It can be any shape like triangular, square, pentagon and hexagon. So on the top of it we have an apex point. We have the apex point. So for this apex point, all the points, corner points of triangle, corner points of square, corner points of pentagon, corner points of hexagon will touch the apex point. Okay. And for the prism we'll be having the rectangular faces. We can have the rectangular faces for the prism, and for the pyramid we have the triangular faces. Okay, these things you have to remember in these types of solids. So polyhedron, so it is bounded by planes called faces, which meet straight lines called edges. So regular polyhedron has face equal as shown in the figure. So if I take a regular polyhedron like tetrahedron, so it is a equilateral triangle. So it has four equilateral triangles. If you join all four equilateral triangles, it become a tetrahedron. Next, a cube, it has a six equal square faces. So one is at the front, second one is at the back, next is the right, next is the left, next is the top, next is the bottom. Total six equal square faces. If you join together, it will become a cube. So similarly, like if you join all the 8 equilateral triangular faces, if you join 12 equal pentagonal faces, and if you join 20 equal equilateral triangular faces, you will get these type of shapes. So in exam they will be asking only about the tetrahedron and cube. They won't go beyond the tetrahedron and cube. Okay. Yeah. So next is a prism. So prism is a polyhedron with n-sided polygon. So the polygon can be any side. So minimum polygon side is 3 and maximum is 1032. So these many sides you can generate a polygon by using the prism. The base which are parallel, and lateral faces are rectangles. So lateral faces are rectangle in nature. So in example they will ask that like rectangular face of a square prism is resting on HP or VP, they will be asking. So based on those things you have to uh, s- generate the stages. And imagine line that join the center of base is called axis. Okay, so you have a bottom face, you have a top face. So when you are joining the top and bottom face, you will get an axis. Okay, so this is also called as vertical height. Vertical height you can measure by using this axis. So prisms are named accordingly as per the shapes of their base. So what is the bottom shape? Based on the bottom shape you will get the shape. Okay, so bottom is a triangle, equilateral triangle. So top also same equilateral triangle. You will be having the axis, and this is the side which you can't see, so you have to represent with the hidden lines. So the hidden lines are to be represented as like a dashed lines. You have to represent the hidden lines. What are the sides you can't see in the front view? You have to represent with the hidden lines. And top and bottom face center of the top bottom face and center of the top face are joined by the axis. So these are the hidden lines. Okay, next is axis. Draw a line, dot, and again draw a line, dot, draw a line, dot, draw a line, dot, draw a line. So these are called the axis. So compulsory you have to represent, try to represent both axis. Hidden lines you have to represent. Axis is optional, but for the stage 1 compulsory you have to represent the axis. For stage 2 and other stages it depends on your wish whether you will be drawing axis or not. Okay, but compulsory you have to draw the hidden lines. Wherever you are not seeing any line, you have to draw the hidden lines. Okay, so these are the faces. This face is a rectangular in nature. So for the prism you have the rectangular faces. So these are the rectangular faces. For any prism you take, you will be having the rectangular faces. Okay, yeah. And if you see the square, you you there are three hidden lines, 1 2 and 3 are hidden lines. If you see the pentagon, you have 1 2 3 4 and 5, total 5 hidden lines you will be having. And if you see the hexagon, 1 2 3 4 and 5, total 5 hidden lines are there. And this is the axis. This is the center of the top face and center of the bottom face are joined by the axis. Draw a line, dot, draw a line, dot, draw a line, dot. You have to represent the axis. So this one is axis. These are the top faces. This is a bottom face. You can call this as bottom base and top base, you can call. So for the prism, top and bottom is same. These are called longer edges. These are because this is a maximum height, so these are the called longer edges. These ends are called longer edges. And these are the faces we call. This is a rectangular face. For the prism you have a rectangular face. For the pyramids you have a triangular face. Okay, next is a pyramid. So in this pyramid you have n-sided polygon. So here also you have bottom face is n-sided polygon. Lateral face are equal and isosceles triangle. So these are isosceles triangle because these two sides are these two length are equal, but this length is not equal to this length. So this is one, and these two sides are equal. So it is called isosceles triangle. You will be generating in the pyramid. Meeting point is at the vertex or apex. So what are the points? Suppose square has 4 points. All the points should touch the apex. This is apex. Generally we represent the apex with the O, and the axis bottom will be represented as O1. We have written. So it is not mentioned here, but there is no labeling here like A B C D 1 2 3 4 the O1 O. There is no mentioning, but labeling you have to do for all these cases. This is called apex point. Top point is called apex point, and this is axis. Bottom face, whenever the bottom face center is touching the apex point, that is called axis. Okay, so axis, draw a line, dot, draw a line, dot. Hidden lines you have to draw the dashed lines, continuous dashed lines. If you draw, these are the hidden lines. So this line, this is a hidden line, and this is a hidden line. These are the sides you can't see because you are seeing in the front. You can see only three sides. Two sides only you can see for the pentagon, and these three sides you can't see for the pentagon. And if you are looking for hexagon, 1 2 and 3, these three sides you can see in the front view, and these three sides, another three sides you can't see in the front view. Okay, this is a front view orientation. Okay, and these are the slant edges. And compared to axis, compared to axis, the slant edges are more in length, more length for the slant edge, and for the axis is smaller length. This thing you have to remember. Okay, and this will be helpful for the development of surfaces. Okay, slant edges are more in length. If you measure slant edges are more in length compared to this axis because it has some inclination. Okay, yeah, so it has a sides are isosceles triangle you have. Okay, this faces is isosceles triangle you have. Okay, yeah, and these are the corners. So they say that in the exam, corner is resting on VP, corner is resting on HP, they can say, or else edge. So these are the edges resting on HP, edges resting on VP. They can ask any types of problem, or else they can say that axis is perpendicular to HP, axis is perpendicular to VP. They can ask any, they can say anything in this exam. Okay, these things you have to remember. Okay, and it has isosceles triangle meeting the uh, corner point to apex. So next, solid of revolution. So if I take a rectangle and if I revolve 360 degrees, then I'll get a cylinder. If I take a triangle and I rotate 360, then I'll get a cone. If I take a semicircle and if I rotate about a 360 degrees, then I'll get a sphere. So these are the different solid of revolution you can have here. So this is my rectangle face of, suppose, of the length and width, and this one I'm rotating 360 degrees. So the object is created. So this is a complete object I can create, and this is a right angle triangle. Taking a right angle triangle and rotating 360 degrees, you will get a cone. If I take a rectangle and generate, it is it is a cylinder. Then this is my semicircle. This semicircle I am rotating 360 degrees, then I'll get a sphere. Okay, so these are the solid of revolution. Yeah, same thing explained. It has infinite number of generators. So this is the main point. So generators are nothing but this is a circle. This is a circle, and I can divide this circle into n number of parts. N number of parts I can divide. Suppose you are dividing into suppose 6 parts you are dividing. Suppose you are dividing into 6 parts, then I can create n number of parts, because this is any, suppose if you divide into distance of 1 meter, 1 mm, then for that 1 mm I can divide into 0.5 mm. If you give 0.5 mm divisions, I will make it as 0.1 division. If you give 0.1 mm as a distance division, then I will give it as 0.001 mm. So like that, it has infinite number of generators are there. This infinite number you have to make it as finite. So for circle, you can make the finite number as 2. You can divide circle into 2, or else you can divide the circle into 4, or else you can divide the circle into 8 parts, or else you can divide the circle into 12 parts. So if you generally, if you divide 12 parts, that will be better. But in exam, if you don't have time, you can divide it into 8 parts. Okay, but don't divide into 4 or 2. You will lose the marks if you divide the any circle or cylinder in 4 or 2 or 2 or 4 parts. Okay, better divide uh, 12 parts, if not divide into 8 parts. Okay, yeah. Generator, nothing but this is a point, this point is touching the apex, same point touching apex. Suppose I created this point and this point, divide into same parts, then this point is touching, this is called generator. Okay, the cone is obtained by triangle axis. It has infinite number of generators. It also has the infinite number of generators, because it is circle. Circle I can divide into n number of infinite number of generators. All these points will touch the apex. So depending on my convenience, I can make it as finite number of generator. I can generate. Okay. Three revolving semicircle around its diameter. So complete 360 degrees. If I rotate, then I can generate this sphere. Next, frustum. So generally frustum is not asked, but it might ask this time. So frustum. So whenever I have any shape and further shape, I'm cutting parallel to base. Suppose the base is on HP, I'm cutting parallel, then I can generate, this is the, I can generate the frustum. Okay, so suppose this is an square pyramid. Example, this is an square pyramid I have. So all these points are touching the apex. So all these points are touching apex. Then I cut here. So what happens is it will generate a square here. Smaller square will be generated at here. Okay. Yeah. So this is a square pyramid. So for square pyramid, I'm cutting. Suppose this length is around 50, and this will be around 20. 20 mm square will be generated by the top. Okay, so like this I can make the frustum. It is nothing but I'm making parallel, so that same shape will be generated, but of different dimension we can generate at the top. Okay, similar I can make it for a square pyramid, hexagonal pyramid, or a cone. I can make it frustum. Next is the labeling. So till now we haven't discussed anything about labeling. So labeling is also important to get the full marks in the exam. So what are the corners? Or there all the corners should be labeled as shown in the figure. So if you see this one, bottom, you have to make it, bottom is a triangle. So you'll get A, B, C. This is for solid. For solid, it will be capital letters. And whenever you are projecting in the front view, it will be small letter A dash. Okay. Whenever you are rotating, you are projecting in the top view, then it will be small letter A. And whenever you are projecting in the side view, you have to write A double dash. So this is a standard representation you should know. And top will be numbers. So here at the end of the axis you have to give O1, at the top apex you have to give O. Okay, so this is my axis line. So here I have to give O1 and here I have to give O, letter O. So bottom four sides I have to give it as A, B, C, D. Top I have to give numbers. So this you have to remember. Whatever may be the case, bottom will be alphabets, top will be numbers. So for here also bottom will be alphabets and top will be the numbers. You have to know. Here also the bottom will be alphabets and the top should be the apex. And this you have axis line, and this axis line you can make it as O1. Compulsory write it O1. At least show in the first stage so that O1 and O. So this will be O and this will be the O1 axis. Okay, so like this you have to remember. Don't forget to give the bottom as alphabets, top as numbers, and axis as bottom of the axis is O1, top of the apex axis apex is O. So these things you have to remember. So similarly, this is for all of the shapes, all for the prism, triangular prism, square prism, pentagonal prism, hexagonal prism, triangular pyramid, square pyramid, pentagonal pyramid, hexagonal pyramid. Bottom should be alphabets, top should be apex here, and bottom of the axis is O1. Similarly, bottom should be the alphabets, bottom of the axis should be O1, and top of the axis should be O, and at the top you have to write the numbers. Don't write alphabets. Don't reverse the order also. So here I have to write alphabets, here I have to write the numbers. These things you have to remember while giving the labeling correctly. Then only you can expect full marks in the exam. So solids are divided into two groups. One is top and base of same shape, which is nothing but the prism. So within nothing but the prism. Next is the solid have bottom I have shape, top I have apex. All the corners are touching the apex. This is nothing but the pyramid. Okay, so there are two cases. One is prism and one is pyramid. So cylinder is one case of prism and cone is one case of pyramid. So prism, triangular, square, pentagon, hexagon. Cube having all the 6 square faces. Tetrahedron having a solid face with 4 triangular faces. Okay, and for the solids, again this is for prism, top face, bottom face. These are the corner. This is the corner, this is the edge, this is a, you have a rectangular face. This is called the longer edge. What are the, it is touching bottom and top, it is called longer edge. So for the pyramids you have the apex. These are called slant edges. This is called base edge. Whenever in the problem they say edge, this is the edge, and whenever in the problem they say slant edge, this is my slant edge. Okay, and it has a triangular face, isosceles triangle face it has. Next cylinder, these are the generators. These are the imaginary lines generated curved surface. So this curved surface, yeah, imaginary lines will join. So this imaginary line will join in the curved surface. And next, whenever we are cutting any of the solids with respect to randomly at an inclination, then you can get shape like this. And whenever I'm cutting parallel, exactly 0 degrees with respect to the horizontal, then I can get as these shapes. Okay, so same explanation. And next is a cylinder. So in the problem they say that axis is vertical. Axis vertical is nothing but vertical with respect to the ground, or HP, or HP. Okay, whenever the axis is vertical, you can see the true shape on HP, and this will be my stage 1, and stage 2 will be this, we can see the height. This is my stage 2, and besides stage 2 I'll get my stage 3, and this stage 3 has an angle of theta. Because it is above xy line, in the first angle projection it will be angle theta. And this one I have to make the projections, whatever I'm getting, I have to make the projection. This will be my stage 4. This will be my stage 4, and stage 4 and stage 5 are side by side. Then here I have to give my angle phi. Angle phi is below xy line. Okay, then I have to make the projection, then I'll get my stage 6. I'll get my stage 6. So whenever I'm getting stage 1, so this is my xy line, this is my stage 1, then stage 2, stage 3, stage 4, stage 5, stage 6. If it starts from the below xy line, it will end with the above xy line. Similarly, if it start with the above xy line, suppose you have a stage 1 or true shape you are seeing here. So stage 1, stage 2, stage 3, stage 4, stage 5, stage 6. It is starting above xy line, stage 1, then stage 6 will be below xy line. Okay. So next is, this is axis vertical or perpendicular to HP or parallel to VP. Anything can be asked. Okay, so this will stage 1, stage 2, stage 3, stage 4, stage 5, stage 6. You'll be getting these. These are the things you'll be getting here. And next is solid. So here they say that axis perpendicular to VP. So the axis perpendicular to VP is nothing but, suppose this is your VP and HP. Suppose this is your VP and HP, this is your XY line. This axis is perpendicular. Then you can see the true shape on here. In this case, for this case, this is your VP and HP, this is your X and Y. They told that axis is perpendicular. So whenever the axis is perpendicular, you can see the true shape on HP. Okay. So here it is, whenever this axis is perpendicular, so this will become as first stage. So for the first stage, you have to make the projections, you will get the second stage. And this with respect to same dimension, the dimension of stage 2 and stage 3 are same. Dimensional characteristics of the object is same in the stage 2 and stage 3. So same object I'm rotating at an angle of phi. Same object I'm rotating an angle of phi, and I have to make the projection. Stage 3 need to make the projection with the stage 4. So here I'll get stage 4. And here stage 4 and stage 5 have the same dimensions or same characteristics of the object. Just I'm rotating the axis. This is my axis. This axis I'm rotating at an angle of theta I'm rotating. And this will be the stage 5. And this stage 5 I have to make the projections. I'll get the, this as my stage 6. Okay. So here stage 2 and stage 3 are the same dimensions, and here stage 4 and stage 5 are the same dimension. This you have to remember. Don't change the dimension whenever it is stage 1, stage 2. So these two are same dimension, and these two are same dimension here. And coming to here, stage 1, stage 2, stage 3, stage 2 and stage 3 are in same dimension, and stage 4 and stage 5 are same dimension. Okay. Yeah, so next is the group B solids. Group B solid cone. So here also they will say that axis is vertical. So this is a vertical axis. So you can see the true shape of the object on the stage below XY. So stage 1, this is a stage 2. Stage 1 projection will be projected on stage 2. Just you have to give the axis height. Axis height is mentioned in the problem. Just you have to give the axis height. Then for this axis height, stage 2 and stage 3 are having the same dimension. Just you are this you are rotating at an angle of theta. This you are rotating at an angle of theta. Make the projections. Make these projections, and then you'll getting the stage 4. And you have to project these things also. This one you have to project, and you have center. This O you have. This O you are projecting here, and this one you are projecting. Then you'll get the point. And this stage 4 and stage 5 have the same dimension. Don't change the dimension. Just this is horizontal line. This horizontal line we are rotating at an angle of phi, and make the projections. Join these projections. Then you will be getting the same shape here. Okay. Similarly, for the whenever axis is vertical, this is the case, and whenever the axis is perpendicular to VP, then you can see the two shape. This is my first stage. You have to draw the circle first, then you have to make the projection, then you have to, for that one, you have to give the vertical height, you have to give axis height, you have to give. This is my stage 2, and stage 2 and stage 3 has the same dimension, just you are rotating at an angle of phi and make the projections. You need to have stage 1 you need to project the horizontal line of stage 1 and vertical line of stage 2 in order to generate the stage 4. And stage 4 and stage 5 have the same dimension, and for here you have to project, then you are rotating at an angle of, just you are rotating at an angle of theta, and you have to make the projections down. You have to make this fourth stage 5 projections down, and you have to vertically down, and this one horizontally you have to rotate, you have to move the projections of the horizontally, you have to move this projections here. Horizontally you have to move this projection where this horizontal line is intersecting with the top vertical line, then you will get the stage 6. Okay. So one thing you have to remember, stage 2 and stage 3 have same dimension, stage 4 and stage has same dimension, except that you are giving some angles like angle phi or angle theta in between. Okay. And whenever axis is perpendicular to VP, true shape is on VP. Whenever axis is perpendicular to HP, whenever axis is perpendicular to HP, true shape is on HP. Okay. These things you have to remember. And next, use of lines. You need to use the different lines you have to use. So whenever I'm drawing a continuous thick lines, then I have to use HB pencil. So whenever I'm highlighting any of the shape, then for visible outline, then I have to use this HB pencil. Whenever visible edges, I have the edges, then I have to use. Whenever I'm drawing the margin line, then I have to use HB pencil. Continuous thin line. So whenever I'm using any dimension lines, or whenever I'm using any for the dimension, I'm using the extension line. Whenever I'm using the hatching lines, and whenever I'm using the projection lines, projection nothing but I have a top view one shape, then I have to make the projection. So this is my XY line. From this XY line, I have take the apex and I'll join this one. So like this, whenever you are making the projection lines, you have to use the 2H pencil. Okay, this use of pencil is also important to get full marks in the exam. Dashed lines. Whenever I'm making any dashed lines, nothing but the hidden lines. Dashed lines are used whenever you have any hidden outlines or hidden edges. For this one, you have to use the dashed lines. Okay. For this dashed lines also, you can use two ways. Next is the long dashed dotted line. So this is nothing but you drawing a line dot, drawing a line dot. This is for center lines or axis lines. You can make it as, you can write it as axis line or center lines. Next is the cutting planes. Whenever you are cutting anything, so in the sections of solids, you will be learning about cutting planes. For the cutting planes also, you have to use these kinds of pencils here. Okay, same thing is explained here. So whenever I'm using the cutting planes, then I have to use like a thick. First I have to use a thick, then I have to use the thin. With thick I have to use with the HB pencil, then thin with the 2H pencil, and again thick with the HB pencil, and again thick with the HB pencil you can make. This is my axis line, center line, axis line, symmetry, pitch of circle, pitch whole circle, everything you have to draw with this one. Dash lines for hidden outlines and hidden edges. This rarely we use, because whenever we have a line of very longer length or infinite length, then you will be using this zigzag lines. So generally we don't use zigzag line in the engine drawing. Like machine drawing, production drawing, you will be using this zigzag lines. So next is a continuous line. Whenever it is a visible outline, visible edges, visible edges nothing but wherever you can see that edge. For those lines, you have to use this continuous line. Okay. And there are different types of solids, such as whenever the axis is perpendicular to HP, axis perpendicular to VP. Already we have seen these two cases, and axis is inclined to HP and parallel to VP. It can be a case axis inclined to VP and parallel to HP, and axis inclined to both HP and VP. So these are the different cases you can see in this projections of solids.